In this video, we're going to talk about how to solve a quadratic by factoring when the a value is 1. So the a value is the number in front of x squared, and so when that's 1, we don't see a number there. When you solve a quadratic in general, you are always looking for these x-intercept points where the graph crosses the x-axis. Not all quadratics can be factored, so you may have to use a different method to solve. Some scenarios when this might happen could be if you are dealing with a parabola that never crosses the x-axis, it would have imaginary solutions, or it might cross at an irrational number, which is like a decimal that cannot be turned into a fraction. Okay, so let's talk about ones that can be solved by factoring. When a is 1, we just want to know what multiplies to be c, and we want it to add to equal b. So I'm going to make a list of things that multiply to be 4, and I'm going to end up with the two numbers that also add to be 5. Well, if I start with 1 times 4 is 4, luckily that already works for adding to 5. So I have x plus 1 and x plus 4 are my factors. This is my factored form. And then what we are looking for is what makes these individual factors be 0, because we want the x-intercepts, and that is where y is 0. So you might not need to write all the solving steps out, but if I was just going to be diligent here and I'm going to write them out, x plus 4 equals 0, I'm setting both factors equal to 0. Then I'm going to solve for x. Well, that's a plus 1, so we use inverse operations, subtract 1, and we get x equals negative 1. I would take 4 away, and I would get x equals negative 4. And so when you go back and think about this, if I had plugged negative 1 into x, negative 1 plus 1 would be 0. And although when I plug it into this factor, it wouldn't be 0, because the first factor is 0, anything times 0 is 0, and so that is why this works. So same thing, if I had plugged negative 4 into the second parentheses, negative 4 plus 4 is 0, so even if the first one's not 0, if the second parentheses are 0, then that would multiply to be 0. And so those are my solutions. Other words for solutions are roots and x-intercepts and zeros. So this quadratic would look something like this. Here it crosses at negative 4, if it crossed at negative 1, so those would be the two x-intercepts, and I would also know that it opens up because a value is positive 1. All right, the next one is not equal to 0, and so we would need to get it equal to 0, and the way we would do that is by moving the 16 to the other side, and it would change its sign. I subtracted 16 from both sides, essentially. So now I see that I have no b value. I want it to multiply to equal negative 16, and I want it to add to equal 0 because there's no b value in the middle. This is a problem that's actually called the difference of perfect squares. X squared is a perfect square and 16 is a perfect square. So what's going to happen is we're looking for a number times itself that multiplies to be 16, and if we make one of those negative, it will multiply to be negative 16, and it adds to be 0 in the middle, and so this works out for us. And I have other videos on just factoring skills if you need more help on factoring before you're ready to solve. So I'm going to show you the steps again of how to get those x values, but if you're looking up here and we ended up with negative 1 and negative 4, do you notice that that's just the opposite of the factors? And so when a is 1, you can just do the opposite of the factors are the solutions. But I'm going to work it all the way out. So I have x minus 4 equals 0. I'm going to add 4 to both sides, and I get 4, which is the opposite. I'm going to set x plus 4 equal to 0. I'm going to take 4 away, and I end up with negative 4. So those are my two x-intercepts. All right, the next one, I have x squared minus 6x equals negative 9. I need to move the negative 9 over by adding it. It will make it be positive 9 when it's on this side of the equation. Now I want it to multiply, I'll abbreviate, to be 9. And I want it to add to equal negative 6. So I'm going to make my table of things. I know that 9 could be 1 times 9 or 3 times 3. Those are the only options. I need a positive 9 and a negative 6. So if I make both 3's negative, they multiply to be positive 9. They add to be negative 6. Those are my factors, x minus 3 and x minus 3 equals 0. Now you might notice Hey, those are the same thing. Yes, they are. Good eye. So I only need to solve this once because there's only going to be one, right? They would end up being the exact same. So there's only one x-intercept this time. And what that means, when there's only one, it actually means your x-intercept is also your vertex. And it would look something like this. That's not a perfect drawing, but that's just a gist of what it would look like. Okay, number 4. Last example for this video. The 3x is on the left, and in the last few examples, I've moved everything to the left. However, my x squared is positive and it's on the right, and I always want to keep my x squared positive. So whichever way you need to move things to get that x squared to be positive, that is my suggestion to you. So I'm going to take this 3x away from both sides. And when I do that, I now have 0 equals x squared. I cannot combine negative 3x with either of those terms because they're not like terms. So I am just going to plop it into the middle. So now I wanted to multiply to equal negative 10. And I wanted to add to equal negative 3. So I'm going to make my table. And 1 times 10 is 10 if I make either of those negatives. To get a negative 10 when I multiply, it cannot be negative 3. Let's see, 2 times 5 is 10, and I want it to be a negative 10, and I want a negative 3 when I add, so I'm going to make the 5 negative so that it's negative 3 when I add them. And so my factors are x plus 2x minus 5. And if you've already caught on that the answers are just going to be the opposite of the factors, so negative 2 and positive 5, you can just write them down at this step. But I'm going to show it out all the way because when we get into factoring when a is greater than 1 and solving that way, it's a little bit harder to tell. I'm going to take the 2 away and I get negative 2. I'm going to add the 5 and that's what gives me positive 5. And so that's why it ends up being opposites. I hope this video has helped you. Again, check out my other factoring videos if you need more practice factoring, and I hope you have a great day.